No new person. All right. So we're going to look at FM technology today, and I would like us to get right into it. It's quite an interesting and voluminous topic, and the way we have structured this course, this module, is to ensure that we touch on all the angles to it, and we can do more research as individuals. When it's time for us to appraise our technology solutions, we have facts that we can latch onto to make our cases, and also how we work with the primary source of data for technology adoption, deployment. It's also key, and that's what we're going to be stressing into this class. Let's look at the core concepts around technology. Every time we talk about technology adoption, new technologies, innovation, we tend to be under the illusion that we are obligated to change the way we are doing things to more innovative ways, okay? That is a big statement in itself, but the driver should not be environmental or external. The driver should be internal, which means our IT and our technology must serve the needs of the business, not the business bending or adjusting to serve the need of IT or technology. So that's the first lesson we need to learn. You must define your business processes and then seek to utilize technology to improve and augment it. So every time I hear someone says we need to roll out the software, we need to implement a certain technology to get things better, the first question that comes to my mind is, how are you currently doing it now? And that had better not be something in your head. How you are currently doing it now needs to be documented using procedural documents, flowcharts, spreadsheets that itemizes what you currently do, with matching records that shows that you're actually doing what you say you are doing. Then we can now look at the challenges, the shortfalls or shortcoming of your current operations, the way it is now. And then we begin to ask questions like, in what areas, in what ways can technology provide enhancements? That's basically what we're trying to do. It has to be something to augment what already exists. If you don't already have a process, or you don't already have procedures documented, technology is useless. If you don't already have records that you can work with, so that's not something we're looking at here. How do you use technology for proactive facility management? First, you want to address current FM problems. What are the things that are not being achieved as quickly as you will want? What are the things that are not being achieved as cheaply as you will want? What are the things that are not being achieved in alignment with strategic goals or corporate strategic goals and objectives? What hiccups, bottlenecks, obstacles do we have that we think technology can address for us now? That's the first consideration. Then you begin to look at operational readiness. This is more like long-term planning. This is more like putting systems in place to ensure that you have a seamless operation. We're not talking about the first bullet item, which was addressing issues or problems. We're now looking at a futuristic approach to proactive FM where you have systems in place to ensure those issues and problems don't occur. So I could already be in operations and I have current FM problems. Technology can help me. I could already be thinking about future sites that I'm going to deploy to, thinking about new operational contracts I need to have in place, thinking about staff I need to onboard, and so on and so forth. And I'm trying to ensure that I have the right technology so that I don't go there and start using stone grinder when there are, modern cutting-edge tech tools to get through that proactively. And finally, life cycle facility management with technology. This is end-to-end data analysis, sensors, controls, and so on and so forth, for me to be able to predict from when I conceive a facility and assets and equipment and installation, be able to predict confidently how long it's going to last, the kind of performance I can get out of it, the kind of data I can get out of it so that I can be able to project forecasts correctly. That's lifecycle facility management using technology. So in essence, I operate facility management at all levels, and technology can be a major tool. So let's look at the three levels of operations or of facility management. We have the operational level where we are doing routine activities, inspections, we are doing the day-to-day activities like cleaning, and the maintenance that take place on a day-to-day basis. Those are the operations and maintenance execution activities. They happen at the operational level. How can technology help at this area? For example, you have your automation of rosters, attendance, bill and meters readings. When you have an energy management system in place, technology can help you, bring all this information in and do analysis. You can use that to manage your expenses, your revenue. You can use technology to do a lot of things at this level. It just makes life easy for you at the operational level. So as a manager, you can manage a large site or multiple sites because you have the right visibility, you have the right data coming in with the right data integrity levels, and you have the right tools for analyzing, trending, forecasting, tracking progress on a day-to-day basis. At the tactical level, you're trying to deal with space management, operations and maintenance plans, and budgets. And you are making a lot of decisions based on the kind of data you have in your technology. For example, there are CAD systems that helps you to do space planning within your facility that can help you project how many people can sit in a particular space for various functions within the organization with certain seating formations. And if that seating formation or furniture formations are tweaked or changed or adjusted using standards that are publicly available, how many more can you get in? How relaxed can you get in space? How can you, optimize the use of space? And this ties into everything, your budget, tracking your budget to ensure that you're not slipping off or varying excessively can be an adult task if you want to handle it manually, right? So technology is there to help with everything, planning especially. You plan, and then when you begin to execute, the information comes back into the same system to help you know whether you're executing as planned, whether there's a variance between your execution and your plans, and helps you to find a trend around how your execution is helping you meet your strategy. At the strategic level, you are doing long-term asset lifecycle planning, capital replacement and improvements, emergency preparedness, and business continuity planning. These are high-level plans. They are strategic plans. They are more. They are where you actually bring in corporate strategies, and you're trying to interpret those corporate strategies to create FM solutions for them. So whether you're going to acquire a new property, the whole analysis of buy, lease, build, for example, can be done using technology. You could do a demographics, the demographics data of your workforce or staff can be imputed in to help you, analyze and come up with the best kind of facility, so that when designers come in and they want to do programming and the rest, you have the right data for them. A lot of things can happen at this stage. Your life cycle cost analysis, for example, when trying to decide between one asset or option or the other, coming at this strategic level. So if you are thinking about facility management at the various levels you deal or render facility management services, you know now that there are technological tools that, and we're going to look at a lot of these options and possibilities in this lesson. But technology, like I said, it's not just for the fun of it. You have to have first an understanding of your business, your organization, what you're trying to achieve. That's the baseline. Okay. From that baseline, you can define clear FM deliverables from the onset of planning. Make the focus, you focus the entire development process in such a way that technology should not come and change you in one direction. Technology should come and seek to know what direction you are going and help you towards that direction. So that's why when picking up a technology or an innovation, fully understand your business processes, fully understand where you are going in terms of your vision and strategic objective, so that we can always tweak and bend and tune the technology to help you meet your need. Not for a technology provider to come in and try to get you to change something about your business to align with the technology. Now, if there's any reason to change anything about your business or your operations, it is because you have documented it. You can now look at it and say, this is not going to give us the best result. Let's do a change on it. It's after you've done that, you say, okay, let me upload all of this into a technology software and get it to work faster. Okay, so that's the whole idea. Handover of deliverable documentation must be in standard digital formats for FM applications. We have standard ISO standards, COBE. We have different standards for data exchange between different platforms. There are hundreds and hundreds of softwares and applications, all over the world right now for different types of technology solutions. Now, if there is no standard formats for information exchange, then we'll either be stuck with whatever we choose or not be able to migrate our data from one system to another. So that's why it's important that you as an FM get a little sense of data formats from your integrators or your software providers. Ask questions so that they can explain to you what standard they have worked to, and then you can now know whether that standard aligns with the other systems you've already used or where your data is currently warehoused. FM data implementation should commence concurrent with the building construction. Data should be populated in an incremental and pragmatic way so as to keep the process manageable and valuable to all. I think we've talked a lot about this. Your building data, it's accumulated from when the building was conceived through construction, all the way to testing, commissioning, handover. All that documentation are built up over time, so that by the time you say come and take over a building, you're not just going to pick up keys, you're going to pick up a pile of data, right? And it should be organized in such a way that it is manageable, it's accessible, it's retrievable. So whether we're doing it on paper, on spreadsheets, on PDFs, on computer files, or we're doing it in a software or certain innovative technological advancement, the first thing to understand is that data is built up over time. And that's why when you take over a facility and the basic data sources that you require are not available, I will tell you, go and see how you can reverse engineer the process, which means go and measure, go and count, go and find specs and begin to document those asset data, because you will need them for your processes, for your operations, as well as when you need to deploy a technology or a software. Including data incrementally ensures the quality delivery, because waiting until the end may result in a large data dump after the interest in the project has faded and contractors are moving on to their next job. And that's why FMs needs to be involved in projects, so that people are giving you information in the format or in the channel or means that you can use it. If you go back to most project people and ask for data and documents about projects that they have left and moved on, I can assure you won't be able to get as much from them as if you were with them while they were generating those records and data to have asked the right questions and gotten what you needed. Let's look at some facility management technologies that we can begin to deploy, from when we have taken over the facility. From when you've taken over the facility, I keep telling you there are certain basic information. You need to have your asset register, for example, and then you need to know the condition. The asset register tells you what assets you have, and then the condition assessment tells you what the condition of those assets are. Very basic, right? Yeah, so how can technology help? Asset tags with embedded data for tracking and monitoring assets and activities. This is very key to information gathering to be able to manage an asset. Then you're managing the assets, you have all kinds of operational challenges. Things like leaks, plumbing leaks can be a big issue. There are sensors nowadays that can be installed along pipelines, especially those that run through certain ducts and causeways, that leaks within those spaces can result in catastrophic or very expensive building repair costs, right? So putting a leak detector or sensor is very powerful technology. And then think about the waste collection system. You have cleaners that go around a large complex, maybe every hour, every 2 hours, just to check if the bins are there, if the bins are filled up. So you have to pay so many cleaners who are loitering the whole place. What if the bins can communicate to you themselves? So the cleaners don't go everywhere. They just go to only the place where the bins are partially full to the point where you will need to take them out, right? So that would be a smart solution, isn't it? And that can actually cut down the number of cleaners you have and the nuisance of their presence during work environment, for large sites. Adjustment to energy demand by household appliances in reaction to dynamic energy pricing. We don't have too much of dynamic energy pricing in Nigeria. I don't know what part of Africa it does, but what dynamic energy pricing does is, because your power plants in the public utilities have a fixed capacity, they are under pressure to raise those capacities to meet the needs of peak periods where virtually all loads are on. So there's often that overcapacity in power plants, so that if they run on a consistent rate of production, then we will be buying 80, 90% or even 100% of what they are producing only for 2 hours. And then they will keep running and will be buying just 20% of what they are producing in off-peak hours. So when they create dynamic energy pricing, they encourage you to move certain loads away from peak period. So that's where they don't have to provide capacity for what is currently peak, because what is currently peak is a lot of loads that shouldn't be running at that time, running at the same time. So imagine if in Nigeria today we had 50 naira for peak time and 10 naira for off peak. You can imagine how many people would turn to nocturnal animals, right? Begin to do a lot of work at night to take advantage of the off peak pricing. And I can assure you that the power plant will no longer require the capacity they currently need to have in place. In fact, with that kind of pricing, more people will move loads away and they will have to reduce the sizes of their engines and turbines, for example. And then they will have more of the outputs steadily being used throughout the period. So those who must have things at peak period will have it there and pay the 15 naira. And most other things would have moved to the night hours of 10 naira. So the power plant will run at the same size of equipment and capacity, and then have probably the same 70, 80 during the day and 70, 80 during the night, right? Otherwise, They would have had so much for the day and very little at night, wasting so much capacity. So that's what dynamic energy pricing is. So for facility managers, if you are in an environment where there's dynamic energy pricing and you are aware of this, you will begin to change the kind of automations you have in your place. We talked during the energy management class a few days ago about switching from level sensors or level controllers, we call flow switches, right? And switching to timers to say, do this kind of work at this time, you know, and for those of us on MD meters, I'm sure, and point loads, I'm sure this dynamic energy pricing will also be helpful. You create automation that makes certain things to work at certain times to take advantage of lower price or reducing your peak. And then you have circuit level energy savings through real-time insights in energy usage by load point. This is a fantastic technology now that, you know, the Enscope meters that we deploy in Max-Migold can measure every circuit, right? So if you have circuit level energy savings through real-time insights, what it means is that you know exactly what is on at any particular time across a vast portfolio nationally. You know exactly what each one is producing at that time. So if energy is being run and you can probe to that line and find out what is that particular kilowatt hours producing right now, it helps you to control things. You can now install sensors and controllers to switch things off. For example, air conditioners running in a room where there's nobody. The sensor says there's nobody, but the AC is still running because somebody put it on and walked away, right? So that kind of information, you know, the sensor that senses no, you know, person, no heated body around, sends an information to a controller attached to the AC, and the AC can go off. And then look at simple Google Maps today. When you are trying to get from one end to the other across town, you quickly pop in the address in Google Map and it tells you if I go this way, I'll spend 1.5 hours. If I go this way, I'll spend less than 30 minutes, right? So that on its own is a technology that helps to reduce congestion, right? And the same thing applies to parking lots. Instead of driving into a parking lot and driving around looking for a free space, simple technology that has a sensor on every parking spot will tell you at the entrance which parking spot is empty at this time. So you drive straight to your point and save fuel. Okay. Real-time access to sensor and surveillance video data. For proactive occupant safety efforts, right? So this is your CCTV. We all are used to this technology, and some of them can respond to certain activities. For example, come on sensing motion, go off when there's no motion for a long time. In terms of video recording, save disk space. Some of them can switch on lights when the motion comes in. When there's activity, it beams lights on it and records at the same time, you know, and so on and so forth for safety, you know, considerations. Data-driven decision-making at all levels of management results in effective solutions to problem. Mobile electronic devices such as smartphones, tablets, and laptops control lights, cooling, and everyday appliances. There are so many systems that have now been integrated with applications for remotely controlling them. And the moment we have Internet of Things, networks, LoRa networks, GSM networks, we're running out 5G across the world right now. Things are now beginning to get connected to each other so that controls can be automated. Controls that are manual are still automated in the sense that you can switch it off remotely. Okay, you can switch off remotely. You can create all kinds of sensors that helps you monitor your appliances and your equipment. For example, you could have sensors that monitor things like vibration levels, heat emission levels, gaseous emission levels, different types of gases, quality of oil, all the various specification of oil quality, all kinds of operating parameters. You can have systems in there that gather the data, and they automatically do the analysis within the software that is the logic that is built into them, such that you can get a trigger, you can get an alarm, you can get some corrective action pre-built in that can shut things down or make them start behaving differently because you've pre-programmed those logic in. Remote building monitoring and control combined with occupant recognition system for seamless security management. Talked about the Internet of Things networks, intelligent information and feedback by monitoring routine habits of occupants. Landscape system measures and takes care of the optimal environment for plants. Right now, if you have a large landscape area, you probably just water at certain times, cut grass at certain time, fumigate at certain time, and you just keep doing those again and again and again. What if you could know exactly how much water the plants needed through sensors? These are technologies that are now so cheap. They have, $2, $5 sensors that can actually monitor moisture level, can monitor plant health, and so on and so forth, so that the water is no longer being wasted and it's no longer being thrown in at random. Water can now be dispersed to the particular plant area where it is actually needed. Talk about street lighting, intelligent street lighting that reduces energy consumption and improves safety of citizens by going off when there's nobody around, no motion, no movement. Sensing motion, comes on and provides light for that activity. Robots and drones, risky surveys and assessment and inspections. When we want to look at our glass panels, to see how their fittings are fixed in place. We want to look at our roof to see how the wind affected our roof. We heard some flapping noise and so on and so forth. And then it's kind of risky and expensive, by the way. It's cheaper now to get a drone fly over your building and do a condition assessment of your fabric than trying to use rope access and hiring people that are very expensive to come running around doing those inspections for you and taking records. Besides, with drones, you have a record that you can refer to again and again. It's not somebody going up there, coming back with some notes, right? Drones will do a proper record and you can revisit it, zoom in again, send it back again to do a more detailed reconnaissance and so on and so forth. Big data analysis. The most likely cause of asset failures for improved reliability. This is just a system of analyzing loads and loads of data. Something fails, you recorded it, what was done to fix it is recorded, how many hours, how much it costs is recorded. So we keep having all this plenty data we've dumped from various work order templates and various logbooks and spreadsheets that we probably are not doing much with. But a big data is just a machine tool for relating those data together and making sense out of them using some kind of cross-functional spreadsheets. Predictive maintenance, data analytics combined with techniques like real-time condition monitoring to maintain asset integrity. We talked about this a bit. And then emergency apps to send an alert in case of an emergency or reportable incidents and can automatically detect the location with audio and video features. When we have an alarm go off, we can only guess what exactly happened, right? But if we have an app with everybody that you can just pick your phone and as you're sounding the alarm, you can report what happened right into that app, then everybody knows exactly the kind of alarm and the kind of emergency that we're dealing with at that point. Smart energy aims at greener energy generation, lower energy consumption pattern with flattened peaks and resilient distribution grid. That's what we just talked about. Smart microgrid distributed generation with renewable resources. So this is not very common around us again. These smart grids where generations can be from multiple points and the grid takes in power and distributes it to the areas of need. And then the metering option, bi-directional intelligent grids for transmission and distribution networks. So there are 7 grids in the world today where you can actually feed in, it's two ways, right? You can take from the grid and you can give into the grid. So if I have a lot of solar panels and I have excess production during the day, I don't need to waste it. I just feed it back into the grid, and the grid gives me my energy whenever I need it or whenever I'm short compared to what the grid has. Metering, that can record consumption of electric energy in real time up to the second, not just minutes. Energy efficiency through smart apps that make consumers more aware of their energy usage and influence them to change their behavior. This is a fantastic tool where you have applications in phones, in tablets, in computers, on TV screens that just makes people aware. Just tell them, oh, you've been in this office, you've used 17 hours of cooling, you've used 45 naira of light for every hour you've been in this office. You know, just something that, you know, intelligently tells you what are the data around your consumption will help you start thinking about energy consumption. So if I'm in the office with 5 people and 75 naira has been spent, I'll be like, okay, that's fair enough. 25 naira each, we're 5. But if I'm in the office alone and 75 naira was spent, and that thing tells me that 75 naira was spent, I ask myself, okay, so why didn't I just go and join the others if I'm not doing something sensitive and so on? Responsive equipment and appliances that temporarily stop consuming energy when demand for energy increases to lower the peak level. So this is a very advanced form of load shedding or load shifting, when the device itself handles the logic. You're not telling the device at this time, if you don't necessarily need to, don't come on so you can work at the off-peak time. You are giving the device information to say, this is what other assets in the facility are consuming at this time. Peak is getting reached. So if you can afford to knock off so you don't increase the peak, please knock off. And you tell that to all the devices and you put them in kind of a rank and file, a ranking order. So each one knows that when we are hitting the peak, there's preference or there's deference to certain assets that must be on at that peak time. The rest of them will, on their own, begin to knock off and give way, just to allow those that must run to run. You've given, so this is the real basis of Internet of Things. You've given all the assets connection to themselves, so they all now can know what is happening to each other, and you can set certain logic into them to help decide which comes in and which does not. Smart water solutions aim at minimizing waste and securing quality as one of the pillars of sustainability. Leakage detection, we talked about that. Water pollution prevention with sensors that can measure the quality of water in real time. So if you have a water treatment system and you do water tests once in a month, once in 2 months, once in 3 months, if you suddenly did a test and realize that, oh my goodness, water is so bad, you can tell how far back that water has been, right? Because the whole idea of doing a test is to find out if you can pick some non-conformity that you need to fix. But that frequency is not going to be good enough for certain environments. So I don't expect a pharmaceutical company or a food production company to rely on water tests, or a hospital water tests that are done once in a month, once in 2 months or 3 months, right? They need to have water, pollution prevention sensors, systems that are in the waterways. The water runs through them, and they're always analyzing, dissolved solids, analyzing E. coli and other bacteria in the water, ion deposit, chlorine, and so on and so forth, on an ongoing basis. Intelligent flood warning can be used to manage, floods and other dangerous weather occurrences. So weather forecasts, we're used to hearing from the Nigerian Meteorological Society or Agency information about how the weather is going to be adverse for social period and so on and so forth. And sometimes they are that detailed that they can even tell you which areas are going to have flooding, which areas are going to have dry spells and so on and so forth, and heat waves. Predictive maintenance on water infrastructure is achieved with sensors in the pipes that measure flow, pressure, and acoustic signals. So a lot of things we can do with technology. But like I said, technology starts from somewhere. We don't just wake up and say, oh, well, I want to go and install a water quality sensor in my 3-bedroom flat, one inlet piping. What's the risk? Do I even drink that water? And if I drink the water, what's the implication, right? For example, if it goes wrong, right? So those kind of analysis needs to happen so that by the time you are investing in technology, you know exactly the value that technology is bringing for you. Many IT initiatives fail due to poor planning and execution. So carefully select an implementation team that's made up of people who are passionate about quality improvement, are committed to open communication, well respected in the organization, and who understand the benefits of facility management technology. Decision-making ability is also important, and these people can work together. So usually, as an FM, don't be the one chairing your technology adoption process. The CFOs are mostly suited because they are the ones that can understand efficiency most easily, okay? They define the roles, responsibilities, and timelines for technology adoption. And when it comes to selection of, because you spend time on your own, understanding your own problem and seeing how your technology can be useful to you, you now need to look out to see what's out there that can solve your problem. So that's stage 2. Don't start looking at technology before you understand your problem and you create a solution for your problem. Because you cannot use technology to create something that did not exist. You create something that exists, you work with it, you document it, and use technology to enhance it. So effectiveness and efficiencies are what technology can bring on board, right? So by the time you get out to start looking out, you're asking people questions. Because if you talk to only vendors, for example, you probably won't get enough information. A vendor will run down the next product just to sell it. So that's natural, right? So hear from as many vendors as possible. Also talk to users of those systems, okay? And then of course, it's important to have a consultant on board. A consultant understands the industry, understands your business, has experience with many other people who have used different softwares, and can look at your business and see the kind of pitfalls you will fall into if you pick a certain software, because some other company that you have engaged with has gone through that route in the past. And then public sources of data like Gartner are all online sources that you can refer to. Many of us don't even bother to look for Gartner. We'll just go to Google and see how we can pick up reviews on what other people are saying about certain products or services. Either way, you need to match some of that information with what you have gathered from personal exposure to others who have used it, as well as the use of a consultant. When deploying technology, ensure that you are planning for the future. Technology should not just be about today. It should not just be about today. Technology is to be able to take care of today's problem and also plan towards tomorrow's solutions. And then, try to understand how data is going to be owned in this relationship with technology providers. Some technology providers will provide their software and you put your data in, and they are the owners of the data that goes into their software. That shouldn't be the case. There should be a way for you to own your data. Very important that you own your data, okay? And so you should have that communication and agreements on how data is going to be entered into it, how data is going to be managed, you have access to that data throughout your use of it, and how data is going to be returned back to you, the owner, and deleted or eradicated from the memory of the service provider or technology provider. That's exactly something you need to also understand very clearly while deploying software. Clarify the additional or indirect costs when doing comparative analysis. Okay. For example, I've had people come and say, "Oh, well, we are buying your license or buying your technology, and once we buy this technology, then you come and implement for us." They have not asked questions around specific details of how that implementation will be done. So when these consultants or technology providers come around to help you deploy, they start asking you questions like, where is your asset register spreadsheet? Where is your process flow? Where is your this? And it start looking kind of funny because you don't have this information, right? So that becomes a big challenge, because at the end of the day, that is something you should have invested in. You may end up realizing that the real cost of them helping you to acquire those data is even far higher than the so-called technology you have deployed. Okay, so don't be a novice when it comes to what is the reality of deploying any technology. What are the costs, both visible, apparent, hidden costs related to that technology deployment? So implementation process, work backwards from go live dates. Always know exactly by what time you need your software working. As you progress, try to celebrate the small wins along the way. It's very important, because as you deploy a new software, new technology, you will have all kinds of obstacles, challenges, things that you must deal with along the way. If you do succeed in taking care of those concerns, then appreciate yourself and your team. Tell your stories. It's a lot of change management that takes place in deploying software and deploying technology of any sort. So we don't take it for granted. Have ongoing feedback protocol set up with vendor. So the vendor is not just going to deploy and walk away, right? It's not just going to deploy and walk away. Vendor should be someone who is happy to stay on and continue to give support. So how is that support going to be measured? How is that support going to be received on an ongoing basis? You need to have that discussion so that as you're signing a contract, you know that support. There was a software a client of mine installed a couple of years ago, and then they needed some support. That was when they realized that they were supposed to pay £1,000 per hour for support. It was outrageous. It was ridiculous. All kinds of things were said about such a support cost. But the reality is that it was information that was provided that nobody looked at during the deployment stage. Okay, so you need to pay attention. Don't take it as something that is taken for granted, because when that happens, you will get stuck. And if you get stuck, that's the end, right? That's the end of that deployment. So we don't want that to happen. Okay. And then when you have deployed, by day one, you can't say you have achieved everything, right? So that's when you really say you need to have a system in place for following up, frequent feedbacks to make sure that people can continue to use it. They understand the software, and they're not going to abandon it midway because of an obstacle. If they have a challenge that they're struggling with, you're able to engage and and solve the issues for them. And then, of course, at the end of every project, there must be a debrief, there must be lessons learned. People must feel a sense of belonging, that they've achieved something significant with that project that has been deployed. Bottom line for all technology deployments is data. Is garbage in, garbage out. Even for the technologies that are the simplest, take your, which one would I give as an example now? You want to install check meters, right? And you want to be able to meter every client, every customer in your organization, in your facility, in your building. And then the wiring is not thoroughly done, that's properly separated. You don't have schematics or circuit diagrams. For example, your DBs are not labeled. For example, you see that metering project with all that, advantages is dead on arrival. You have to go back and ensure that you have proper labeling of your DBs. Circuits are aligned to be able to put meters in points where you can get data, and so on and so forth, right? So the whole idea of thinking about technology is to start thinking about the people, start thinking about the solutions you're trying to create. So that's really it. You want to create solutions for people, you want to create results for the business, you want to provide professional solutions for a built environment that is functional, that is aesthetically pleasing, that is health safe and secure, right? So in essence, for us as facility managers, we cannot cry over data that we didn't get from construction. We all know that it's at construction we will get all of this data to make our lives easy, but we must also learn that if we don't get all of this data, because we're not there,
they will flog in school.
That we can still
be doing that your style. Yeah, I don't understand.
Some of the information that are required I put this list together as basic outline, information you must have in place to manage your facilities effectively. Okay, but before we get to that, I'll first of all look at the tools. Yeah, you're going to have computer-aided facility management. You're going to have CAD systems, integrated work management system, computerized maintenance management system, like CMMS, enterprise resource planning tools, energy asset management, building automation systems, and so on and so forth. We'll talk about some of these in subsequent slides. I just want us to follow the class sequentially. We'll talk about BIM as well. BIM is building information modeling. It's a tool or a system that enables us to organize information and make them retrievable from a visual interface. So there is what we call a digital twin, where you are building or trying to build something in real life, and you're building it digitally as well. All the data, all the information that will go into the real one now represented in that digital copy. That's what BIM does. So you can actually, harness the information, add more information, retrieve information, access information on a state-by-state basis as the asset is being developed. Routine operations, lifecycle management, and capital plan requires information, unified visualized information base. All of these are some of the things that you get. We're going to talk more about BIM as we go on, because everything from space planning, location of building components and equipment fixtures, identifying and scoping building issues would come out of the kind of visual data that BIM does for you. So this is the list I was talking about, the inputs to FM information system. Things that must be in place for you to say, I'm managing this facility, right? I actually have this documentation. If I didn't have them, how many of them can I reverse engineer, can I produce by studying the building, measuring, counting, scanning, and so on and so forth. Number one is the as-built drawings. The as-built drawings is not just architectural drawings. It should also include electrical, air conditioning or mechanical drawings, plumbing drawings, just basically even structural drawings. They help you get a lot of information about the facility that you're managing. Comprehensive asset register. So this is, something that's very key, where you get information about the assets that you have, the accounts, their specifications, their series, their models, and so on and so forth. As-built bill of quantities. This is very important. So you can get specifications of the things you are managing. If you're having a certain floor tiles in your building, you probably cannot guess whether that is a vitrified tile, a marble tile, a granite tile, a porcelain tile, a ceramic tile, or so on and so forth, right? Because nowadays, finishing or look and feel of various flooring types can, one material can be used to produce 5-6 different types of finishing appearance, right? So you can't look at the floor and say this is wood anymore, or this is, granite anymore, because those are things that have been created. But then each of those materials that is used to make those floor finishing or covering, for example, have different things that you will need to work with them with. For example, certain chemicals will not, work with them. You can't use the same kind of chemicals on granite and marble, right? Marble is like chalk if you got through the surface. And certain chemicals will just, cave in and cause holes on them, even if it's whether it's deliberate or it's a mistake, right? Then you need to have construction snags and defects. Every time they're building and they're handing over, they pick up snags and then they fix those snags. Because you are going to manage this facility for a long term, there are telltale signs from those snags that were fixed that will help you connect the dots when you're trying to find the histories of certain defects you're going to deal with, all right? And then people that build should not just disappear into thin air. The construction team and the vendor details should also be something you have on hand. I know how people try to fix this these days by keeping 1 or 2 staff from the construction team to stay behind. Instead of going for the proper documentation, you now depend on what's in somebody's head who was around during construction. That person become indispensable to your troubleshooting, diagnosis, problem solving, and proactive facility management, right? That becomes a bottleneck, if you ask me. Equipment guarantees and warranties, very important, especially the terms stated in those warranties. Don't just pick up a file and say, this is where all our warranties are. We have warranty, we have guarantee for this and that and that. We have 2 years warranty. You need to understand the terms of those warranties. Many of us have killed our warranties even before we have issues to invoke the warranties for. By the time we call for the warranty implementation, we are told that you have done ABC, which contravene the terms of that warranty that was issued to you. And then operations and maintenance manuals. Everything must have O&M manual, everything. If there are woodwork in the space, what's the O&M manual for woodwork? Windows, aluminum windows and doors, what's the O&M manual for that? Floor claddings and wall painting, what's the O&M manual? Because you must know what are the main components or ingredients that make up those assets and how you can maintain them. What kind of activities you need to perform in their maintenance and operations, and what are the frequencies for those. They give all of those in your O&M manuals that should come to you as an FM. But if you don't have it, then what do we say? Your maintenance program becomes a reverse engineering process of generating this documentation. And then regulatory permits and other legal documentation. You have boreholes, you have elevators, you have all kinds of things. They all need to have certain permits, big diesel tanks and so on and so forth. Testing and commissioning results, this happens at before the handover stage and then ongoing after handover. You're gathering data on functionality, how the facilities and assets are meeting their functionality requirements, and also how they are meeting their adequacy requirements. So testing is for functionality, commissioning is for adequacy. And as you're gathering this data, it's helping you to understand the facility more and more in such a way that you know certain failure patterns that could easily rear their ugly heads, and you get a sense on how to handle certain use patterns, because you could overload a certain aspect, and the other area is not as loaded, and now looks as if this area loaded is the one that's having a problem, when the reality is that you've not used the facility in the balance. Corner information for equipment manufacturers. So the equipment and assets that are installed, the equipment manufacturers play a key role when you're looking for spare parts tomorrow, or you're looking for certain information on certain upgrades that needs to happen. Building systems and equipment specifications, of course, I tied this down to the bill of quantities. Being able to have specifications for every material is the bill of quantity, but the system itself, for example, what is the capacity of this central air conditioning system? What's the British thermal units rating? What's the kilowatt hours it consumes, and so on and so forth? What's the true strength, and so on and so forth? And then the components that make up your equipment and your assets. All right, so you need to know exactly if you have a cold room, for example, you need to know that it doesn't have certain components in it. You need to know what makes up that cold room, the main components, right? And then you need to also have spare parts lists. So the item that can easily wear, tear, and be consumed or run out of use in your asset needs to be understood. And that's very key to your facility management of that site. So currently, we can't take too much credit for how well we have managed the built environment. Information is just not available, not just available. I can tell you that even with all these border constructions, new estates, and large developments ongoing, information is still being either not released to FMs or released in formats that are disjointed, just disorganized and very difficult to make sense out of. It's still a big issue. We still have, design teams, construction teams that are delivering drawings in 2D AutoCAD, saved as PDF, printed and handed over to you. That's a rubbish data, because that PDF that you have been given, you can't do much with it. You can only look at it. If you've been given the source file, the CAD drawings, for example, then you can say, okay, let me see how I can manipulate this information, triangulate and get square meters for irregular shapes, and get a lot of information from it, and there's so many information that are embedded into it that will not be printed when you print it out, okay? And so, you can read up all of this. These are issues you can relate with. Many of us have been part of construction. Many of us have been part of taking over buildings that have been built, and boy, you can tell how much garbage comes out of construction, and it gets to you. I mean, if you get the garbage at all, some don't even get any information. You're given the keys to the property, and you're supposed to decipher everything else and make sense of it all. So at the basic level of technology deployment, you want to move from papers, logbooks, and spreadsheets to a software. So that's where the computerized maintenance management system comes in, right? So this is an effort to automate your activities, to automate especially your maintenance activities. So what you have in the CMMS is just a simple software that you've logged all your asset data into it, which means you now know what the components of each equipment is, you know what the spare parts are. If you have a store, that inventory is there, so that when things come in and go out of store, when they are used for certain asset replacements, you can account for them in there. Some go as far as having details of all the vendors who bid for certain jobs and handle the bidding inside the platform. But it also includes your in-house staff, outsourced staff, and the roles they will perform in the maintenance and operations process. And all of these are done in such a way that whenever any activity takes place, it is saved back into the CMMS, and every activity is tied to a particular asset, which is tied to a particular space in your facility. So the CMMS is at the basic level the primary tool for managing operations and maintenance in facility management. And some of the things, we talked about how to manage the business side of making a case for it. Is what this slide is talking about. Get buy-in and commitment from management. If you don't get buy-in from management and all you got was approval to spend money, then you can still fail in that project. They approve you to spend the money and you didn't get their commitment to it. When they need information or need data tomorrow, are they willing to insist that that data come out of the software you have used? Because if your senior management begin to get people to work outside of that software, then that software is doomed, right? Define requirements, including goals, expectations, hardware, and timelines. List of assets will be entered into the CMMS is very key. That's why your asset register must be intact. Document all planned preventive maintenance procedures. So like I said, buying the CMMS does not help to create the activities you perform, the frequencies of those activities, who we do them. You have to first of all detail those ones out. The guys who are bringing the software to you, they want you give it to them by hand, and they look at it and say, no, we don't like it in this format. Take this template and go and copy and paste this template and give to us to upload for you. Basically, that's what they want to do. As simple as that, right? So you must ensure that you have your processes and procedures in place, and then you pick a software that helps to achieve what you are there to do. You import the data, and then sometimes some softwares are actually able to extract data from another software, which is a good thing, right? So data interfaces and handshakes, is very key. It's very key. Okay. And then of course the users have to be configured in with their various authorization levels and various activities and the various assets, information assets, and then add scheduled maintenance and set triggers to go live. Okay, and then of course when you have a CMMS in place, it doesn't just run itself. You have to keep working it, renew it, refine it, customize it to meet your needs continuously. If you want to go a step further beyond the basic maintenance of your facilities, you need to go to a computer-aided facility management software, which is CAFM, a CAFM system. What this now includes is all of that maintenance plus all the operations. Okay, so your space and how the spaces are managed, reporting on all your operations, rosters of people, HRO, vendor management, procurement processes, energy metering and solutions. You put all of your operations data in here. You can even use to manage attendance of workers and the rest. So it's more expansive. The CMMS is a module inside the CAFM software. So you can do things like visitor access automations. You could do identification. You could do all kinds of screening, and all the data will be right inside the space of your CAFM system. Okay, so CAFM is a bit more comprehensive than the CMMS, because CMMS is a module inside CAFM. So some of the same characteristics and features we've talked about the CMMS and all the other technologies we've looked at today also apply to the CAFM. Because once you are moving away from the free tools of papers, logbooks, and spreadsheets, somebody's going to spend money, isn't it? And there must be proper business cases. There must be a refinement of that data to be ready to move into any other more sophisticated software. Maintenance budgets can be a challenge. Management somehow, for many industries, they commoditize services. So if it's not cleaning and if it's not replacing the light bulb, everything else you're talking about is, subjective. So they don't approve so much money for doing some of this technology. And if they don't see the need for it, you have either of two problems. Either you are trying to go for technology for the sake of technology, that you cannot really define the need for that technology. You cannot even show that there's going to be cost savings with deployment of that technology. That's a big issue that you may have to deal with. Or sometimes it's not even needed, right? You don't have the need for it because your processes are not so complicated to the point where you need help to automate or optimize them. Okay. And then resources can be an issue. How many people you have in-house? How many of them know how to use computer to the level of being able to run a CAFM system? And then, of course, some funded mandates where, oh, well, we want to have its wishes that did not, say if wishes were horses, beggars will fly, right? And then distributed data and data disparities. Many of us don't have the kind of data that can go into a software. And then sometimes organizational stovepipes. This is where you have departments and functions within the organization having different recording mechanism, having different tools for managing their data. The challenge for facility managers is to overcome this obstacle by utilizing the resources available from convincing leadership that efficiencies and cost savings can be achieved with investments in technology such as a well-planned CAFM system. I've talked about BIM. More information about BIM here, intelligent 3D model-based process that equips building professionals with insights and tools to efficiently plan, design, construct, manage buildings and infrastructure. So basically, it's all about data. So even if we seem to portray BIM as images, visualizations, but the data that goes into a BIM model is mind-boggling, right? It's just phenomenal. Okay, you could generate spreadsheets upon spreadsheets of different aspects of your BIM model that gives you insights, details, data about the physical characteristics of every of those components that are built in. I'm looking at a roof and it looks like a very fine red or brown roof. But I can't know by looking at it whether it is, concrete tiles or it's aluminum, because aluminum could be grated and frosted and given different effects and colored to look like concrete, right? Until I look at the kind of data I have in my BIM model, I won't get a sense of what exactly I'm looking at. So it's a very important tool in the construction industry, and we have very few people. We have very few people that are getting into BIM to develop. It's cutting edge. It's the foundation of smart buildings, foundation of smart cities, smart infrastructure, because you need to be able to have a level of data, an information requirement level that is high enough for decision making, for all kinds of things you want to do. If you want to install sensors in a building, for example, if you want to change a system in a building, for example, you need a BIM approach. And because it is one central workspace where all professionals who work inside, it helps for coordination, it helps for improved productivity, it helps to reduce rework, it helps to give everybody insight to what the next person is doing and reduce all the hours spent in meetings and asking questions, because you can just see everything from one interface. Now, so those are tools for managing our services in the built environment. What about technologies that are built into the building, right? So some of those technologies I discussed earlier on when I looked at all those sensors and IoT devices for automating water flow, energy management, and the rest. But when we're looking at it holistically, there are two technologies that form the basis for building controls, managing the building itself, not the services we provide to the building. And the first one is the BMS, the Building Management System, the control system that can be used to monitor and manage the mechanical, electrical, and electromechanical services in a facility. It's installed as a standalone application or can be integrated with other monitoring programs. It monitors and manages a wide range of building services across multiple platforms. What the building management system basically does is give you information on what's happening at various points within the systems that you've built into your facility. So if I put in an air handling unit, air handling system into my building, there are ducts, there are air handling units, there are chiller units, there are fan coil units, and then all those spaces that those systems and components are serving. I need to know what's exactly going on within those spaces. I need to be able to get information on the operating parameters of everything. So if there are vibrations, I need to get that information to see whether it's within threshold, if there are emissions, if there are leaks or moisture gathering at certain points. A building management system is just a series of sensors that brings information to a central point so that I can now use those information to intelligently act with regards to what that component asset equipment is. And then a building management system can also be built in with a control system. So I can have not just a sensor that tells me the AC is on and how many kilowatt the AC is working, running with. I can also get a sense of if I now decide to switch it off. Let's say I went home and I found out that 20 air conditioners were left on in my high-rise building. What can I do? Can I log into my BMS system and shut down those air conditioners? Yes, a BMS would allow me take such actions, right? So that's the whole idea. Control. I monitor and control. I monitor and control. All right. So when people are complaining about, oh, it's too hot, it's too cold, I go and check. I see what the ambient temperature is. I look at the temperature of the chilled water and the air that the chiller system or the handling unit or fan coil unit is releasing into that space, and then I do a correction by running some controls. Okay. Now, so a building that has a BMS is not a smart building. It's a building that can give me information and gives me access to controlling from a central point. But a building that has a building automation system is a smart building. It's an advancement or enhancement on the BMS where I don't need to take specific actions to, when I observe data, to come and act on things, to shut down, to open more or close, right? I don't need to do that. I write in all the logic of the standards that I have in my head that I need to implement. So if I see CO2 level, for example, being on the high side, which means oxygen level is low, and that place is becoming uninhabitable for people. In a BMS system, I would, remotely or from my central command point, open a certain damper. There's a valve that I can remotely control, or it's wired in anyway, so I can control that valve. It opens in, opens out, allows fresh air to mix in with the air in that air handling unit, and the oxygen begins to become enriched, and the sensor begins to tell me oxygen is becoming high enough, it's becoming high enough, it's getting, it's optimal. And then what do? I go back and switch off that valve that brings in fresh air. That's in a BMS system. But in a BAS system, it is further integrated so that the oxygen level at which that control valve should be opened is programmed into the system, so that when oxygen level drops and there are people up to a certain threshold or numbers in a certain space, the system automatically opens to allow oxygen in. If people leave a space, I don't need to, in a BMS, I'll look into that space, look at the sensors and see there's nobody there. I can shut things down. But in a BAS system, the system does that automatically. People leave, it shuts things down itself. Let's take a 2-minute break. I'll be right back. One of the main advantages or benefits of the building automation system is the removal of human errors in all forms of controls. It saves you a lot of energy. when things are automated. You don't have any lapse or loss of time between when it's observed and when the action takes place. Environmental impact is reduced as well in every area. Improves security, building maintenance, it's seamless, operator convenience. You don't have to do too much. You don't run kitty at all when you do the BS. Everything seems to run in a seamless fashion, and you save time getting things done. So everything from lights to air conditioning to cameras to sound system to all kinds of controls are done by a BS system. Finally, it's 70% of technology deployment, lack of realistic that all the problems we've had will be sorted out, right? So that can be a misleading proposition. Lack of specific outcomes. You didn't really specify clearly what you want to achieve with that technology. Lack of commitment, especially senior management commitment. If there's somebody at the top who is just playing along because some approvals have been given and there's money to spend and is not really committed to technology, you won't make any headway. And lack of planning. Sometimes we tend to believe that the providers of softwares are supposed to do all our planning for us. No, all of the work is done in-house. Lack of quality, especially in the area of data, quality especially in the area of documentation that already exists, because it's garbage in, garbage out. Lack of communication, being able to carry people along. If people see it as your project, it will end up as your project. They won't use it, don't use it to your field. And lack of authority as an FM. You can't force people to get things to work. If people bypass it, you can't do much. So you need to use much of leadership and communication to get through this lack of authority. So that's our lesson for today. Let's hear your questions. Okay, Jude, let's hear from you straight away.
Thank you very much, Mr. Paul, and good evening. Good evening to everyone in the class. My question stems from BAS, and I just wanted to know from your own experience, what is the cost-benefit ratio of acquiring a BAS to the savings it is expected to generate?
From deploying an energy management system, which is a form of a BMS, not a full BMS, just to monitor energy consumption, you could have payback period of less than 3 years. A BAS system with all of that data integration and automatic controls can pay for itself faster. So in terms of cost benefit analysis, there's a huge gain, and that's something we can also do for you. In this platform, we can look at the data you have on ground and do a business case for you to share with your management. Of course, a little bit of a consulting fees attached, but you could there are certain templates you can generate for putting together your data and showing management the value of deploying a BAS. For facilities like yours, your head office, Jude, I can tell you that you can get paid back in less than 24 months. It's huge, because everything from energy, from data accuracy, from security, that are very concerned about security, you're very concerned about safety and health, all of those things that when you begin to put figures in terms of monetary values on them, management will be astounded by the kind of data that comes out of the benefits of having a BAS system installed. And in times past, people installed BMS by wiring up the whole buildings. Now, wireless systems, LoRa networks have helped to create BMS systems or BAS systems that you don't even need to go start, hacking walls and piping or wiring anymore. Everything just going to be seamless. You just tack and drop things, tag things around, and then you have your data, and all those controls work sweet from not just from your location, but also work remotely. So I can actually have my BAS system installed, and I can have access to all of that information, data, visuals from wherever I am on my phone or my laptop. So yes, cost-benefit analysis, from my experience, is really tremendous. It's amazing. The opportunities are huge for BAS systems.
Okay, thanks, Mr. Paul. So with this, is it possible to have multiple sites on a single BMS system, even if those sites are spread across the country?
That is now a BAS system. You cannot do BMS across multiple locations. BMS is one location. In fact, most BMS are wired in. Okay. So if you want to have multiple locations, then what you probably now need is to have each of those, of course it's possible, each of those central control modules in your BMS connected with an internet module. What an internet module does is moves all of that data into a cloud processing point. And that place can now have all the other BMSs across the country also bringing their data in there. You cannot create an interface for studying that data and analyzing and taking decisions and even acting from that central point in the cloud. Yes, it's possible.
Thank you very much. I'm very much interested in this. So I'll still be engaging you from the back end on how we can do this. Thank you.
Fantastic. Thank you so much. Well done. Okay. Thank you so much, guys. I hope you've learned something. This particular course does not have an assignment or an assessment. It's interesting, but we're going to leave it like that. I'm not going to create one because the one I've given you last week is still coming in. I think I want every assignment in today. So take this free space, but please keep researching on technologies that you can use to solve whatever challenges you're having right now. Okay, don't relent. Thank you, guys. Have a nice evening. Bye-bye.
Thank you, sir. Bye-bye.
Bye.
Yeah, thank you, sir. Bye-bye. Wow, thank you, sir.